Hello? Okay, perfect. So thank you for inviting us over. We're going to be talking about mind.ai. My name is Paul Lee, and let me start off with the video. If I can find it.
Corporations and nations hoarding the most innovative scientists, engineers, and researchers. It's deterring our collective brainpower from creating projects that may solve global humanitarian crises to merely producing systems for profit, surveillance, and war. The AI arms race rapidly progressed us through the second wave of AI, in which deep learning through brute force statistical computations led to superhuman achievements in several domains. Second wave systems produce extremely accurate results, but its mistakes can be fatal, as we've seen with recent autonomous vehicles. To make matters worse, it's extremely difficult to pinpoint what went wrong within these black boxes. Mind.ai was created to tackle the limitations of these second wave systems and bring forth the third wave of AI. Mind is an artificial intelligence powered by revolutionary, internationally patented data structures to perform deductive, inductive, and abductive reasoning. By parsing natural language and breaking down information to its most fundamental level, mind is able to contextualize every detail. This entire process is transparent, allowing us to pinpoint and surgically correct exact points of error. We plan to open source the Mind engine and distribute the ontological database to promote a democratization of power in the AI space today. Building a community of intelligent minds around the Mind ecosystem can allow us to turn the tide of the AI arms race, promote benevolent progress rather than narrow self-interests, and ultimately advance humanity as one.
Okay, so at Mind, we have a totally new paradigm in the symbolic AI industry. So we don't deal with parallel computing, supercomputers, or tons and tons of data. We found a way that a simple triangular algorithm can offer reasoning. And we need to look at what reasoning actually is. So when we say we reason, that means being able to adapt to environments, being able to verify facts, new facts that you attain every single day, and being able to process that to solve problems. So reasoning is associated with intellect, cognition, as well as just thinking. But when we say reasoning, these three components of abductive reasoning, as well as inductive reasoning, and deductive reasoning has to happen all at the same time. If you only have two or one, we can't say that thing or that one or that person is able to reason. So let me give you an example. So I have a 4-year-old daughter whose name's Gloria. So I was going to talk with my daughter. I took her to the car, made her sit in the front, but obviously my wife, she doesn't want the little daughter sitting at the front. So I made a little promise saying, okay, we're not going to tell Mom, but you're going to be sitting at the front and we're going to go to the mall. And then my wife calls and she says, okay, how are you guys doing? So I said, okay, we're doing fine. Gloria's sitting right next to me. We're fine. So I hung up the phone. The next, I looked around and my daughter was a little angry because she was like, Dad, you actually broke a promise. And I said, what promise? She said, well, you said you're not going to tell Mom that I was going to be sitting at the front. And I said, no, I didn't tell Mom that you were sitting at the front. I told her you were sitting next to me. And then she said, and this is a reasoning process of a 4-year-old. She said, okay, if I'm sitting next to you and the driver who's actually driving is sitting right at the front, that means I'm sitting at the front as well. So that reasoning process is happening in a 4-year-old. We're saying that can happen with a machine. So this is our unit of reasoning. It consists of adoption on the left-hand side, deduction on the right-hand side, and induction on the back. So the primary going to resultant with a context. These canonical structures will form networks to form and solve problems in what people disciplinary problems. We have an international patent that we got in 2017. It took us 12 years to get it. It took 12 years of hard R&D. So what is differentiation? And this is it. So it's a new symbolic paradigm. We don't use neural networks, so we don't need tons and tons of data. We work with natural language, which is one of the most hardest and the difficult unstructured data out there. We're saying we can structure this in a canonical way and solve problems. The brittleness of the symbolic paradigm has been solved through our augmented topological network. What that means is the structure, as you can see, can be a node and a link, and the canonical can be a node and a link at the same time. It's linear, qualitative, and it's human understandable logic. That means we can trace back and see where it came from. We don't need tons of data. For example, AlphaGo, you need tons and tons of playing data. For us, we need to tell it rules, how to play the game of Go. And it will understand that it plays the game of Go, and these are the rules, so I can play and I can adjust the player's movement. It's transparent. All the symbolic canonicals can be traced back. We can surgically remove if anything goes wrong, and we know exactly how it came to the conclusion. So it's not a black box. It's language agnostic. That means it can be in Chinese, it can be in Arabic, it can be in Korean, it can even be in a programmable language. And it's universal. So it doesn't just have to be in the medicine area, it doesn't have to be in drug discovery, it can actually be in finance, it can be in multiple disciplines. We want to make it open and decentralized because we want to give it back to the community. We want it to be like electricity. We want everyone around the world to participate and use our technology to further advance humanity. So our ecosystem consists of ontologists. So ontology is like the fuel for our core engine. Ontologists will be around the world, they'll be in our community, feeding the core engine so that we can learn and advance. Then developers will be able to use our APIs and develop apps. The whole ecosystem will be using the currency what we call one tokens. So the current roadmap, 2017, we did a massive patent internationally. 2018, we are now generating our tokens. From the product side, we have the engine development done. So the core engine, although it's embryonic, it works. We're going to be launching beta, about 2 to 5 dApps within this year, and 2019, Mind ecosystem will go live. So the two main important things that we're interested in, our engine can actually learn to learn. When we get to a critical mass of our ontology, it will be able to go out into the world and collect information, and it will be able to digest that and reason with it. That's never been done before. The next thing is meta-theoretics. We're saying an artificial intelligent machine can actually form its own theories, like the relativity. It will be able to go back, look at all the data, all the facts, and come up with its own theories, whether it's drug discovery, whether it's a shopping assistant for e-commerce, whether it's virtual mentors, whether it's automated coding. There will be a future where we won't even have to code. We'll give it constraints and it will be able to code on its own. Asset management for finance, diagnosis, and even new treatment paradigms. What about personal secretary like Jarvis? But this is only primary. We have to look at the secondary and the tertiary and the quaternary. Like the internet came from computers which were powered by machines, but also, due to the internet, Facebook, Ubers of the world were developed. We're saying we don't know how it's going to evolve, but we're urging that there is a way to solve AGI. And we think we've cracked the first surface. We're not saying we've done it and we've solved it. That's why we're urging the community to help us move forward. And this simple triangular canonical, this is the way we're going to actually solve AGI. Thank you.